All right, we're going to continue with our review of the chapter 4 exam. And chapter 4 is all about the topics of functions that kind of didn't fit anywhere else. And so we talked about looking at whether the graph of a function is increasing or decreasing. We talked about translating functions by moving them in the coordinate plane. And then we started some topics about combining functions. First, combining them arithmetically by adding, subtracting, multiplying, and dividing them. And then we looked at combining functions using the composite function. And so we're going to start this morning on problem 5 in your review on combining functions using arithmetic, adding them, subtracting them, multiplying, and then dividing them. All right. So let's look at problem 5. We've got a function f of x equals x squared minus 6x, and g of x equals 4 plus x. And the first thing we're going to do is we're going to combine them by adding them. We're going to find the sum function. And to find the sum function, we literally add the two functions together. And this is why in this review class earlier, we reviewed adding algebraic expressions together because you are going to be asked to combine like terms. So what do we have? We have x squared minus 6x, that's f of x. So I substituted the expression x squared minus 6x for f of x. And what's g of x? 4 plus x. And then I am going to combine like terms. I have a minus 6x and an x, and I'm going to combine those. Minus 6 plus 1 is minus 5. And there is the sum function. All right. The next thing we're going to do is find the difference function. And I'm going to warn you to be super careful to make sure you actually subtract g of x from f of x. So again, f of x is x squared minus 6, and then I'm going to subtract, and I'm going to put g of x in parentheses, just so I make sure that I subtract the whole thing, 4 plus x. So when I subtract an algebraic expression, I distribute that negative across, so I get minus 4 minus x, and then again I have like terms. I have a minus 6x and a minus 1x. So I get x squared. I need to ground myself here. When it starts making weird looking writing on my iPad, it means I need to ground myself. I've generated some static energy. All right, so it's x squared minus 7x minus 2. Minus 4, I don't know what I just said. Okay, now we're going to find the product function. And to find the product function, we're going to multiply the two functions together. So we're going to just simply multiply those two functions together. And I'm going to do that by FOILing. So I have x squared times 4. I have x squared, my iPad thinks it's helping me. I have, stop doing that. I have x squared times x, which is x to the third. Okay, I will get this. Inside is -6 times 4 is -24x. And then last, I have -6 times x is -6x squared. And I can combine like terms. I've got a couple of x squares in here, a 4 and a -6. So I'm going to combine those. So I have x to the third. 4 minus 6 is -2. Minus 24x. And then last but not least, the quotient function, which is the easiest of the 4 to find. You just divide the two functions, but f of x over g of x. But then I have a could you guys get off your phones, please? Thanks, appreciate it. I don't expect people to do that when I'm at dinner with them, and I don't expect you to do it while I'm talking to you in class. Yes. Just a kind of a pet peeve of mine. I mean, if you don't want to be in class, that's fine. You can go ahead and go, but to sit there on your phone the whole time. All right. I need to find the domain of this thing. And to find the domain, I set the denominator equal to 0. And that is the restriction on my domain. X cannot equal -4. And in interval notation, that is everything to the left of -4 and everything to the right. So everything except -4. So that's -infinity to -4 with a parenthesis from -4 to infinity. All right, the next problem we are going to do on our calculators. We have, don't try to do this algebraically. Let your calculator do this. So we're going to put f of x in y1, and we're going to put g of x in y2. And then we are going to simply add those functions together on our calculator and evaluate them at -1. So we're going to do all of this on our calculator. Okay, so let me open the calculator up. I need to share the screen here. How many calculators do I have open? I can't do this. I honestly can't. All right. So in my y equals, in y1, I'm going to put f of x. And I have f of x from my problem is x squared minus 3x. So I'm going to put that in. And then in the y2, I'm going to put g of x, 6 minus x to the third. Okay, so I have f of x in y1 and g of x in y2. Now I'm just going to get out of there. I don't need to graph them or anything like that. I'm simply going to evaluate those functions at whatever value I'm evaluating them at, and then adding them together. Okay, so the first thing I'm going to find is f plus g at -1. So f plus g at -1 is f of -1 plus g of -1. So I'm going to go find that variable. I'm going to go to my variables menu, my y variables, my function variables, and I'm going to hit enter on the y1. And to evaluate that at -1, I just put it in parentheses. So that will evaluate the function f at -1, whatever that's going to equal. And then I'm going to add to it y2 evaluated also at -1. That's going to give me the sum function. And we get 11. So f plus g at -1 is the number 11. Okay, now I'm going to evaluate the difference function. So is everybody awake and watching? To do that, all I got to do is go up there and highlight that, hit enter, and then walk my way back and make that a minus. I think, what are we evaluating it at? We might be evaluating it at a different number, at 3, but that's okay. I went too far with the minus, that's okay. We're going to evaluate this at 3. So I'm just going to change this to 3. And it might have been just as easy for me to type it in. And, you know, maybe that's faster than going in there and finding the variables. I don't know, you know. And I got 21. Oh, I made a mistake. That's okay. And on your problem, it's actually y2 at 3 minus y1 at 3. It's g minus f of 3. I made this same mistake in my notes. So I'm going to go ahead and do it. Find my variables, my y variables, my y2, evaluate it at 3. See, I tried to take a shortcut and it never works. And I'm going to subtract from it my variables, my y variables, and I notice I don't have a parenthesis there. I'll fix that. y1 at 3. And I'm going to go back there and insert a parenthesis because I forgot it. So go second, insert that parenthesis. So that should work. And it's -20. Okay, the next thing I'm going to find is f times g at -1. So I'm going to go to my variables, my y variables, my function, y1 at -1. And I'm going to multiply that times y2. At -1. And I made some kind of mistake there. That's a net, that's a minus, not a minus. There we go. That's better. Maybe. 28. Okay, and last but not least, they want you to find g, the quotient function g over f at -2. So I'm going to go back to my y variables. y2 evaluated at -2 divided by y1 evaluated at -2. And I did it again, didn't I? That is a minus. I'm ready for Thanksgiving. Is that still 3 weeks away? Okay, I do get 1.4. That doesn't bother me. My math lab is expecting a fraction. But to change a decimal to a fraction, you go math. Number 1 is 7/5. So the answer to part D is 7/5. You can change any, well, not any decimal. If it can be written as a fraction, you can change that decimal to a fraction. Irrational numbers are decimals that cannot be changed to fractions. Okay? All right, the next problem we're going to look at is the composite problem number 7. F composed with G of X and G composed with F of X. To find F composed with G of X, we're going to evaluate our function F at G of X. So in our function F, where there is an X, we're going to replace it with G of X. So wherever there's an X, we're going to write G of X. So that's going to be 6 times G of X minus 4. But G of X is 5 minus 3x. So that's going to be 30 minus 18x minus 4, which is what? 26 minus 18x. Okay, then we're going to find G composed with F of X, which means to evaluate the function G at F of X. So in G, where there's an X, we're going to replace that with F of X. So we have 5 minus 3 times F of X. 5 minus 3 times 6x minus 4. 5 minus 18x plus 12. We're distributing a minus across those two terms inside parentheses. So it's at 17 minus 18x. All right. Total revenue function for a certain product is given by R equals 460x dollars. And the total cost function for this product is C equals 25,000 plus 40x plus x squared dollars, where x is the number of units of the product that are produced and sold. Find the profit function. Well, the profit function is what? Profit is revenue minus cost. So we're just going to, that is the difference function. So we're just going to subtract those two functions. I have 460x minus, in parentheses, 25,000 plus 40x plus x squared. So what I end up with is 460x minus 25,000 minus 40x minus x squared. So what do I get? Negative 25,000 And don't write it with with the comma in there, by the way. Plus 420x minus x squared. And then it asks you for, this is from the last chapter. Once you have the profit function, how do you find where profit is maximum and how many units? That's the vertex. This is straight from chapter 3. So how do you find the vertex? You can find the vertex however you want to find the vertex. You can certainly graph that to find the vertex. You could certainly do that. I'm just too lazy to graph it because, in my opinion, finding the vertex by just using the formula when there's something that you're going to have to mess with the window. I mean, I'm going to have to mess with that window quite a bit to find that vertex. So I am just going to find the vertex using the formula. So the vertex can be found, and I'm going to write it down here. X is minus b over 2a. Because if you get problem 9 wrong, I'm going to send you an email and yell at you. If you get problem 9 wrong, then I have failed as a teacher. Trust me, you are not going to get problem 9 wrong. All right, so it's minus b over 2a. B is 420. And a is -1. There's a -1 right there. And B is 420. And so what's that going to be? Is that going to be 210? So if I make 210 of these, whatever they are, I'm going to be at my maximum profitability. And then I'm going to evaluate this function at 210. So I'm going to use my calculator to do that. And I do believe I forgot to share my screen over here. Yeah. Okay, so what did I have? I have X is 210. And I'm going to show you 2 different ways to do this on your calculator. Both work very, very well. The first way is just to plug it in. So we had negative 25,000. See if I can actually use the negative key. Plus 420. Plus 420 times whatever X was. What was X? Was it 210? And then we're going to subtract from it X squared. So we're going to subtract 210 squared. And we get 19,100. So our maximum profit is 19,100. Okay, I'm going to show you the second way to do this. You can type in the function. You can type in the function. So you type in negative 25,000 plus 420x minus x squared. Okay, and then I'm going to hit enter, and it's going to give me some weird number. That's okay. But now I'm going to tell my calculator what I want to evaluate this at is 210. Are you ready? So I go 210, and I'm going to store that. You see the store button right above the on? I'm going to store that next. And now when I go back up and highlight that function and evaluate it, do I get 19,100? So it's probably faster to store the 210 in the X first then type that algebraic expression in and then hit enter. So you can do it either way. You can plug in the 210 yourself and let your calculator evaluate it, or type it in exactly the way the function is in your problem, and then store whatever value of X you have in there. Okay. If I can actually share my screen this time. All right. All right, problem 9. What do inverse functions do? Inverse functions interchange the X's and the Y's. They interchange the domain and the range. That's what inverses do. So if this is my function, this table, and that table is my inverse, do you know what you do with the X's and Y's? So if the first ordered pair is -3, -13, what's the ordered pair in the inverse? -13, -3. So if the second ordered pair X is -2, what's Y in the inverse? What is it? -2. If the X in the inverse -9 is -9, what's the Y in the function? You can say it. If that's -9 there, what does that have to be right there? Thank you. You get this wrong, I'm gonna yell at you. So this has to be -9, -5, -1, and 3. This has to be -2, -1, 0, 1. Done. You interchange the X and Y's. I guess I could write that down. Okie dokie. Find whether the function graph to the right is 1-to-1. How do you determine if a function is 1-to-1? Does that pass the horizontal line test? Okay. 2 functions. Let's blow them up so we can see them. Of these 4, which one is the graph of a function in its inverse? And it absolutely, positively can only be one of them. The other 3 are decidedly not a function in its inverse.
A or D?
What's that?
A?
You say C?
No. C.
It's C. Now, how do you know that?
Because the red line is the original, like, standard function, and the blue line is the inverse of it.
And that's a good explanation. See if I can make this. There are a couple of different ways you can determine for sure that it has to be C. Now, I don't know on your test, I don't know if it's A, B, C, or D. But in this case, the reason I know it's C is because of what it does. A function and its inverse, when graphed, are symmetric about the line that's 45 degrees and goes through the origin. So the line Y equals X. So I should be able to take the blue graph and rotate it around that line and get an identical graph in red, which I do. The other way you can tell it's the inverse is by simply looking at a particular X and Y value. Looking at the blue graph appears to have an X-intercept at maybe -1.5. So its inverse must have a point at Y equals -1.5. Inverses interchange the X's and the Y's. So if I have a point -1.5 here, I have to have a point -1.5 here. I have to, okay? It appears that I have a point on the blue graph on the Y-axis at close to 1. So on the red axis, I have to have an X value that's close to 1, and I do. So they have to be inverses of each other. Up here in the blue graph, it appears that I have a value at 1.1. So I would have to have in the red graph a point at 1.1. I don't. They are not inverses. This one over here, it appears, well, it looks like we got some points here, so that's okay. But it appears that the blue graph goes through someplace close to 1. So 0 someplace close to 1. Well, that one does too. That one has some of the points the same. Let's see what else we got here. But they're not inverses of each other. They are not. Because if I rotate that blue graph around this way, I don't get a matching red graph. And then those, no way. No. No way, no how. All right. Time do I have? The function that models the percent of children taking antidepressants, well, that's depressing. Is f of x equals -0.03x plus 2.93, where x is the number of years after 2000. What's its inverse? So to find the inverse, we first write this as y equals instead of f of x. And then I interchange the x and y's because that's what the inverse does. And then I solve for y. So I'm going to subtract the 2.93 from both sides. And then I'm going to divide both sides by -0.083. And I could leave it that way. That is a perfectly fine answer. That's fine. They're not expecting you to do that division. They don't really care. Now, I could, if I were so inclined, multiply the numerator and denominator by -1 to get something that looks like this. I could do that. But it's not necessary. Okay, so if the function gives me the percent of children taking antidepressants from 2004 to 2009, what does the inverse do? The inverse gives us the number of years after 2000 when the percentage of students taking antidepressants is equal to 0. That sounds right. Because the inverse does the opposite. So if the function gives me the percent after 2000, then the inverse would give me the number of years after 2000 given the percent. So that sounds right to me. It's not going to give me the increase. No, that's not right. That increases the giveaway there. Inverse gives a percent. No, it's not going to give me a percentage because I'm taking the inverse. if the original function gave me the percentage, the inverse is not gonna give me the percentage. The inverse is gonna give me the number of years. Okay, in what year is the percentage of children taking antidepressants equal to 2.5%? So we're gonna evaluate this function at 2.5. Take your handy dandy calculator out. And my handy dandy calculator says that's 5.2. So that's 2005. Solve the equation, the cube root equation. I'm going to raise both sides to the third power. When I raise a cube to the third power, I get the stuff underneath the radical. Honestly, do. And 5 cubes, 125. So x is 121. All right. I would actually, you could have solved 14 graphically. I'm going to solve 15 graphically because I know for a fact that I'm not going to get both solutions if I don't. So I'm going to solve it graphically. So I'm going to share screen, and I'm going to go to my calculator. And I'm going to do problem 14 first. So I'm going to go to my y equals and clear out what I got in there. And I'm going to put in the cube root of x plus 4. And you can find the cube root in your math menu. It's number 4. The cube root of x plus 4. Or you can raise it to the 1/3 power. And then I'm going to put 5 in y2. And I'm going to graph it. Oh, I got stat plots on. I got all sorts of things going on here. Turn the stat plot off. Then I'm going to do a zoom 6. It's obviously intersecting way out here somewhere, and I did find 121, didn't I? So I'm going to do a window change, and I'm going to make that x max 200. And make the scale 10. And then I can find the intersection. $121. Okay, and then number 15, there ain't no way, no how that I'm gonna be able to solve that and get both solutions. So I am going to graph that. So the left-hand side is x plus 5 to the 2/3, and I lost my x somewhere. I'm going to raise that to the 2/3. 2 divided by 3. And the right-hand side is 9. I probably need to go back to a zoom standard. It's above what I can see in the y direction and in the x direction. So I'm going to change my window to negative, I don't know, 100 to 100. There you go. So what are the two intersections? It looks like it's intersecting at -3 and maybe +2. So there are two solutions. Like I say, it looks to me like -3 and +2, but well, actually my scale's off, isn't it? My scale's like 10. So let's find the intersections. First curve, okay. Second curve, okay. My guess, I'm just going to go over there and move close to that. So it's crossing at 22, it's intersecting at 22, so one of my solutions is 22. Calculate the second intersection. First curve, okay, second curve, okay. And then I'm gonna go over here toward that second intersection for my guess. -32. So the solutions to this equation is -32, and what was the other one? 22? If I solve this graphically. And I'm just gonna type those two answers in, separated by a comma. Okay, this next one is quadratic in form. This is what we talked about on Monday. Since 2/3 is double 1/3, I can rewrite this as 2u squared plus 5u minus 12 equals 0, where I'm letting u equal x to the 1/3. And I can factor that. Four and 3 and plus and minus. So 2u minus 3 equals 0 and u plus 4 equals 0. So I'm gonna say, and therefore u is 3/2 and u is -4. I added 3 and divided by 2. So x, if I cube both sides, x is u cubed. If u equals x to the 1/3, then x is u cubed. So it's either 3/2 cubed or -4 cubed. So it's either what? 27/8 or -4 times -4 9 times -4 is -16. We haven't done these yet. This is what we're going to finish up today. We haven't done problems 17 or 18 yet. But I am going to look at them anyway. There is a property of absolute value inequalities that says if I have the absolute value of an expression less than a constant, then the way I solve that is I put what's inside the absolute values between the positive and the negative. Well, it's a C, not a 12. I got my head ahead in my hand, my hand ahead in my head, I don't know. So if I have 3x minus 9 is less than 12, then 3x minus 9 has to be between -12 and +12. That is all there is to that problem. That's literally pretty much it. Now, the second thing it says is, okay, then what's the graph look like? Well, let's go graph it. Okay, so I'm going to go into my calculator and I'm going to graph this. So the first part, I'm going to graph the left-hand side of that absolute value inequality. So I have absolute value of 3x minus 9. To find my absolute value, I go math, number, and number 1 is absolute value. And we had what, 3x minus 9? And then the right-hand side was what, 12? And I'm gonna do a zoom standard. I'm gonna have to change my Y window to encompass that 12. I'll make it 15. So where is this absolute value graph less than 12? Where it is below it. So where is this graph? Which graph is this? I think this is A or C. I think it's C. Those are kind of hard because those graphs look very similar. Let's see, what's the units? It's either A or C. And I think it's each unit is 5, 10, 15, 20, 25, 30. So since this thing in 5, 10, 15, 20, 25, 30, so it has to be C because the second value, second thing I graphed was 12. And in part A, it's on the 5, 10, it's on 10. Well, that's hard to see. But there is a subtle difference between A and C where that horizontal line is, and a horizontal line is at 12. Okay, so where is this graph beneath? Where is the absolute value beneath? It's beneath 12 between whatever those two numbers are. And I can go find the intersection. I'm just going to tell you what it is because I'm out of time. It's between -1 and 7. So this intersection right here on the left is -112. And the one on the right is 712. So it's between -1 and 12 that it's below that horizontal line. Okay. Solve f of x is greater than 0, greater than or equal to 0, and less than or equal to 0 graphically. Where is this thing greater than or equal to 0? Where it is above the x-axis. Where is it above the x-axis? From -1 to infinity, or less than -1. And where else is it above the x-axis? From 2 to infinity, or anything greater than 2? Where is it below the x-axis? Then it's the opposite. If it is above that way and that way, it's below in between. So where is that going to be? Smack dab on time. Are there any questions?